Reaver is the standard tool for retrieving WPS pins. We'll explore it here. We now demonstrate how to use reaver together with the pixie dust attack to retrieve a WPS pin. First, we look at IWconfig as usual. So we see that we are already in monitor mode. If not, we can always turn it on. We do arrow dump minus ng -0 to look for our target access point. In this case, we're looking for Daniel Wireless, which is here. So it's on channel 11 and with a particular SSID. So we can stop and we begin with the use of reaver. So that's reaver. In the past, reaver and pixie dust might be used separately. So reaver would understand the EAP protocol and the exchange of messages, and then it will capture some data that pixie dust would be used subsequently in an offline way to analyze the data. These days, reaver is integrated with pixie dust, so we just run reaver with a particular option to get pixie dust involved. So it's quite straightforward. There's various options, as we can see here. If we just do reaver by itself, we can look at the different arguments. But anyway, let's use the basic reaver with this wireless then 0 minus B. So as I mentioned, it's Daniel Wireless, which is this BSS ID. Copy, paste, and make it verbose so we see what it's doing. And here's where we bring in the pixie dust attack. Even as we're gathering data with reaver, we'll be using the pixie dust attack to analyze it. So minus K equals 1. And then we know it's channel 11, so minus C11. There was a previous session that I had been trying earlier, and we can just restore it. I just started for a few pins. So yes. Now, notice that reaver is helpful in the sense that it will keep your previous session results, so you can continue again later and not have to wait very long. And there are various mechanisms whereby wireless access points will make it more difficult for people to find a pin using tools like reaver. So for example, you might have to wait before trying with a new pin. So this can be a bit annoying, but it just slows down the attack. Since the maximum possible number of different valid pins is only 11,000, at least that we need to check. So eventually we should still be able to retrieve the pin. But this is more than 60 seconds, so we may have run into another AP protection mechanism where the AP will actually disable WPS rather than just wait. We will try to connect to the router to see if we can do something about that rate. Now it's interesting that various sort of countermeasures are implemented in access points. So I see on my router configuration screen that there's this option here which says enable router's pin, and that in parentheses it says disabled because an attack is detected. Some APs come with such detection features. So let me enable the pin again, and then we won't have to keep waiting. But it still seems to not be working. Let's take a look at the router settings, and maybe there's something else. And I'm going to disable the router protection feature that automatically disables the pin after 3 failed attempts. I can change the number of failed attempts to a larger number, but I'm just going to try to disable that, and hopefully that will make things faster. Okay, so I'm applying it to the router. We're still waiting and waiting. No, that's way more than 60 seconds. That's the problem with some of these tools. Sometimes these are not polished pieces of software that we might be used to from big software companies. So problems like this can happen. Maybe there's a bug and could be waiting 60 minutes or who knows. Let me just try to restart this. Maybe that might be easier. Restore the previous session. No, not that either. That didn't seem to help. Let's try to run arrow dump ng to figure out what's going on. So arrow dump ng wireless LAN 1, and let's see if maybe the router might have changed channel. Yes, we see that it has switched to channel 1. When I reset the pin, it had gone to channel 1. So okay, that's why it's waiting forever for this beacon. So these sorts of things happen. Routers have their own way of doing things. So in this case, it had switched to channel 1. So good thing for us, we checked. And now it's trying more pins. It's taking a while, and we have speeded up the video meanwhile. So it's triple speed. Yeah, okay. Try another one. Yeah, it's kind of annoying sometimes this because of router protection mechanisms, so it can take a while. Doesn't always succeed in associating. And again, we are greatly speeding up the video. It's something like 5 times faster than usual now. And when it does succeed in associating, then it goes through this protocol here, trying the candidate pin, but it wasn't the right pin. We're speeding up the next almost 2 minutes of reaver action and making it fit into about 10 seconds. Sometimes we see WPS transaction fail, and we can do a minus no next. That's a suggested way of dealing with it. We're seeing a 4 times speed up in the 16 seconds of video. Yeah, so we didn't get that same error because we set the minus no next. Another speed up. Trying different pins now. And here are the next 5 minutes of reaver action, greatly speeded up again. However, we see that we still have all these problems with difficulties associating with the access point. So this is caused by the signal strength of the access point not being strong enough. And what can we do about that? We have one more trick up our sleeve, because if we don't do something about it, it's just going to be too slow. In this portion of the reaver action, we only get to try 11 pins, and it will take a long time to get to 11,000. So what do? We can improve the signal strength by using a stronger directional antenna.